In our last video, part one, we looked at what a logarithmic function was and how to go from logarithmic to exponential and then from exponential to logarithmic. And then we also finished that video up by evaluating logarithmic functions. Here, we're going to look at logarithmic functions, but in a word problem format. So here it says, the air pressure outside of an aircraft can be determined by the equation P equals B times 10 raised to the negative 9h over 100, where B is the air pressure at sea level and h is the altitude in miles. If the air pressure at sea level is 14.7 pounds per square inch, write an equation to find the height of an aircraft when the air pressure is known. So all we are doing is going to be writing an equation. So to do that, we need to put in 14.7, that's for the air pressure at sea level, and B in our equation is the air pressure at sea level. So I'm going to start off with P equaling, and I have 14.7 times 10 raised to the negative 9h all over 100. Now I need to solve for h. That means I have to get h by itself. To do that, I'm going to first get the parentheses by itself. So I'm going to divide by 14.7 on both sides. And now I have P over 14.7 equals, I have 10 raised to the negative 9h all over 100. Now I have to get the exponent down. And when you're working with exponents, to get the x in exponential form, when you're trying to get the exponent down, because that's where the variable's at, you have to do the inverse of an exponential. And the inverse of an exponential is logarithm. So I have to take the logarithm with the same base as the base of the exponent, of the exponential. So if I take the log base 10 of 10, log base 10 of 10 is 1, which means they undo each other. And that would mean I would have the exponent now down below, so it would be negative 9h all over 100. But whatever I do to one side, I have to do on the other. So that means I have to do log base 10 on the left-hand side. So I would have log base 10 of P over 14.7. Now my final step is to get h by itself. So I would multiply by the reciprocal, which would be 100 all over negative 9. That leaves me with h on this side equals, whatever I do on one side, I have to do the same thing on the other. So this would be 100 all over 9. So my final answer to get h by itself would be a negative 100 over 9 times log base 10 of P over 14.7. And then from there, if you know what the air pressure outside the aircraft would be, you could plug a number in there and use the functions given there to find the height of the aircraft. Next example. Here it says the computers of steps that a computer program takes to analyze an algorithm can be modeled by y equals 2 raised to the r power, where r is the running time in seconds. Write the inverse of the function. So if this is an exponential form, I would just have to change that to logarithmic form. So again, if I were to rewrite this as 2 raised to the r equals y power, I would start with my base, and I would have log base 2 of y equals my r. That would be in logarithmic form. If I were to solve it differently, I would just switch my x and y around. So switching my x and y around, my x in this case is my r. So really, I would actually have this written as 2 to the y power is equal to my x. But we're writing the inverse of it, and the inverse of an exponential would be logarithmic. So our inverse function would be log base 2 of y equal r. Moving on to our next problem. Here we have one with tornadoes. It says the distance in miles that a tornado travels is y equals 10 raised to the w minus 65 divided by 93, where w represents the speed of the wind in miles per hour. Write an equation to find the wind speed when the distance traveled is known. So to do this, for part A, we need to get the exponent down. In order to do that, we need to find the logarithm. So undo an exponential by finding the logarithm. So right now I have y equals, I have 10 raised to the w minus 65 all over 93. So to undo this, I'm going to find the log base 10 of 10, which means they undo each other. And that brings my exponent down. So I have now w minus 65 all over 93. This is going to equal, if I multiplied one side by log base 10, I have to multiply this side by log base 10. So now I have log base 10 of y equals w minus 65 over 93. Now, to get w by itself, I need to first get rid of my denominator. So I'm going to multiply by 93. That gets rid of the 93 on the bottom here. Multiply this side by 93. And now I have 93 times log base 10 of y equals w minus 65. And my final step, just to get my w by itself, I'm just going to add 65 to both sides, and I would have w equaling 93 times log base 10 of y plus, so be plus 65. And this would be my equation. Part B says, use the equation to estimate the speed of the wind to the nearest mile per hour if a tornado that travels 50 miles. So if I go back to my answer of 93 times log base 10, so I have 93 log base 10. My y is my distance. So I'm going to put 50 in for y equals, if I go back, not equals, I got to do the plus. So the plus 65. And now to do this, I'm going to grab my calculator. So now we're going to type in 93, then the log button. Now you'll notice that it just says log. Log base 10 is just log. Okay. If it's in any other base, then we have to put that change of base in there. But right now it's just log base 10. And I type in 50 and parentheses and then plus 65. If we hit enter, it gives us 223.0042104. Now, if we're going to round it to the nearest mile per hour, we would just say the wind speed would be roughly 223 miles per hour. Moving on to our next part. Now graphing logarithmic functions. A function of the form f of x equaling log base b of x, where b is greater than 0 and b cannot be 1, is a logarithmic function. So the graph of f of x equaling log base b of x represents the parent function, so that would be in red. The exponential is in blue here. So if I had f of x equaling 2 to the x power, the inverse would be log base 2 of x. And you'll notice that we have our line of reflection here, and our asymptote is now no longer the x-axis, it's now the y-axis. Okay, so we're going to work on graphing logarithmic functions. The parent function is log base b of x. These are continuous functions, which just means there's no jumps or gaps in there. They are one-to-one, which makes that a function. So it passes the vertical line test and it passes the horizontal line test. The domain, notice the domain is now, it's going to be all positive numbers bigger than 0. Okay, 0 is neither positive nor negative because the y-axis, which is where x is 0, that's our asymptote. So the domain is going to be all positive real numbers, or you can say x is greater than 0. And then the range will be all real numbers. Now for exponential functions, the domain was all real numbers and the y value was y, or the range was y is greater than 0. Now they're just switched because they're the inverses. And our asymptote is the y-axis, or you can think of it as x is equal to 0. The x-intercept, we have an x-intercept instead of a y-intercept. So the x-intercept would be 1, 0. It's increasing when b is greater than 1. So when you're looking at the x-intercept, it's above the x-axis when it's less than, actually for this one right here, when it's greater than 1. And it's decreasing, that means it's going down when b is less than 1 but greater than 0. And remember that increasing and decreasing is always going from left to right. Positive, negative means when is it above the x-axis and when is it below. It's positive when it's greater than 1. So when it's to the right of 1, it's above the x-axis. When it's less than 1, but it's greater than 0, it's below the x-axis. And then the extremas, we don't have any extremas on there because the range is all real numbers. So now our first one to graph, before we get to the first one to graph, just looking at the end behavior here. For a function f of x that is defined at a vertical asymptote, x is equal to c. C is just referring to which direction are you going from. Are you going from the positive side or the negative side? So you could say it's when x is, you wouldn't want to say that x is decreasing, because if you're saying that x is decreasing, you're saying that it can go to negative infinity on the x-axis. That's not true. So we're just going to say that as it approaches 0. And from which side? Are you approaching 0 from the positive side or from the negative side? And that's all they're saying right here. So this would be saying as x approaches 0 from the positive. So when I'm going left from the positive side, my y value is going down to negative infinity. And as x increases, as it goes to the right, my y value reaches positive infinity. All right, and then the last thing we're going to look at is transformations, but I'm going to share that in another video. So our next video I'm making, I will graph and then show the transformations.